Okay, hello, good afternoon. And first, I want to apologize if maybe I talk too fast because I'm so nervous right now. My name is Valen, and I'm a research assistant in Universitas Gadjah Mada, and I've been working with Andy for almost 12 years. In this section, wait, why can I? Okay. In this section, I would like to share my experience working with Probit analysis. Yeah. Just a quick disclaimer, I'm an expert in statistics, but I had a bit of hands-on experience working with Probit analysis over the years. So there are three main things that I will covering today. First is what is Probit analysis? And then how to prepare data for Probit analysis, including the key requirement and common challenge. And then I will share my experience using 4 different software to calculate the LCV from GMP, SPSS, Pola, and Excel. Okay, I will not talk too much about this because Andy already explained a little bit. What is probit analysis? It is derived from probability unit. It corresponds to normal distribution. So in example, if you have 3% mortality, so you will have a probability unit of 0.5. So about this conversion, you can find a lot of tables in the internet freely. And it would, with probit analysis, we make the dose response modeling, and the key outputs for analysis are slope, chi-square goodness of it, and fiducial limits. So first, I will show you the ideal probit dataset. There's predictor here, and then the response. So when we draw the plot, we can see here that the scatter plot and the curve is quite linear. So in Probit, we usually require 3 different variables. First is the predictor, or we usually use concentration, and then the total number of infected and the response, or the total mortality. And the second is the near ideal Probit dataset. As you can see here, that there are 4 top concentrations which have 100% mortality. So I made 3 different schedules when plotting the graph here. You can see that. Oh, wait, I can see it clearly. You can see here that I make blue line, red line, and green lines. Blue lines made from complete data set. And the red line is the data set, which include only 100% mortalities. And then the green line is the analysis using the data, exclude the data which have 100% mortality. As you can see here, that the blue line is inflated, so we have maybe a flatter slope, and then the green is good but less accurate. We did not include the 100% mortality, which can help us to estimate the LC95 or LC99s more accurately. And then this is the first problematic case when we have outlier from pooled mortality. So you can see here, there are some mortalities in the lowest concentration, which suddenly higher than the higher concentration, I'm sorry. So you can see here that it will distort the curve. So you will have less fit model. In this case, we can exclude this. After that, we can have a more reliable curve, or maybe more fit data, more fit model, I'm sorry. And then the second problematic case, when there are outliers within the replicates. As you can see here, there are some extreme mortalities in the mid range of concentrations. In this case, you can consider to exclude these 2 replicates. then because we avoid removing data or cells in the middle of the concentrations because it may ruin the pattern. So after you exclude the first and four replicates, you can have a better model. So next, I will share my experience with Polo, GMP, SPSS, and Excel. So this is the user interface for data input for Polo. Here is Polo, and this is SPSS, and this is GMP, and this is Excel. As you can see here that GMP, SPSS, and Excel have similar user interface for input data, but Polo it has a more specific user interface. So Polo, you can either make a txt file from Notepad to input the data, or you can manually input the data to the program. And then you can choose to calculate and setting which model that you want to use. It's Probit or Logit. And then is there any validity in natural response? And then you can input the value of LC that you desire. And this is the output. For Polo, Probit analysis using Polo is considered good if, wait. You can see here the T ratio is more than 1.96. And then here you can see the value of the LC 15, 95, and 99. And this is the chi-square and degrees of freedom. And then you can see in the bottom right the heterogeneity. For Polo, the model will be adequate and fit if the heterogeneity is less than 1. And then Polo, you can generate the regression plot also, but it's basic and you cannot customize. So for me, Polo is fast and lightweight, and it's very clear because it's designed specifically for Probit or Logit models. But you cannot enter fractional or percentage data, so you can only input raw data. And there's limited plotting or customization, and it's also paid program, but it's cheaper than GMP or SPSS. And this GMP, it's like if you want to input the data in GMP, it's like when you input the data in Excel. And then you can start with analyze, choosing the fit model, and then choose the Probit platform to run the Probit analysis. And here is the result. GMP automatically shows the Pearson or defines goodness of its statistic or the chi-square. Probit analysis using GMP is considered good if the p-value is not significant. If it's significant, it will turn into orange, and there will be asterisk in the behind the number. And then one thing that may be still confusing to me about GMP is the slope, because GMP doesn't show it as a slope, but as a log of concentration. And it's different from Polo, I'm sorry. And I don't know why actually. And you can use the option of inverse prediction to show which LC that you desire. And these are the value of LC 15, 95, and 99 with the confidence interval. GMP also automatically show the residual, but you can also use the option to show the linear predictor plot. The next, for me, GMP is visual friendly and flexible. They have very much information. If you want to use it, because there are plenty of options that you can use, but it doesn't automatically correct for natural response. So you have to manually calculate with Abbott correction if you have mortality in control which less than 20%. And at first it's quite confusing because they have it has a lot of features. And it's a paid program but very expensive. And next is SPSS. SS and GMP share similar way to input the data, but then you can use the menu to analyze it and choose the regression and then Probit to run the platform. And here you can see the slope. The slope appears as concentration because input the predictor as CONC. And then this is the Pearson goodness of it or the chi-square. So it is fit because it's not significant. And SPS also automatically shows all of the value of the LC levels. So you can choose which LC levels that you desire. For me, SPSS is easy. It's easy, but SPSS also handle natural response corrections like Polo. But if control mortality exists, use natural response option and select value, so it won't affect the degree of freedom. But for plot, it's limited in comparison to GMP, and it's also paid program, but it's less expensive than GMP. And the last one is the hardest one, Excel. I did Excel for learning how the Probit works. So I use the steps from this book published by IRI, and it's free. There are approximately 29 steps. And you have to use the log Probit paper to make the eye fit a trend line. And with Excel Probit analysis, consider the good fit if the difference between Probit regression from provisional line with the expected Probit is less than 0.2. And the calculated and in comparison to tabulated chi-square is bigger. So it is the adequate model fit. So for me, Excel is transparent because you can see all the steps to generate the value. And it's good for teaching or learning how Probit works. It's usually free because it comes in bundling with your laptop, but it's really time consuming and error prone. Requires various tables and interpolations. And you have to make a lot of, you have to use a lot of log Probit paper to make the eye-fitted trend line. So basically, if you want to use Excel, use it to practice, not to calculate the data that you want to publish. So I ran the data from slide 3 with 4 different programs. As you can see here, that only GMP shows different slope because I don't know how it handles the slope. But the others are quite similar. And the LC50 also, LC95 also not too big difference between programs. And the goodness of it suggests adequate model. But then I also run a data where mortality in control group is 0. So I only input the raw data. I did not to correct with Abbott formula first. And when I ran with the 3 different programs, I did not run with Excel because it's time consuming. As you can see here that the LC50 actually same. LC95 also only 0.02. So actually the programs generate the same values.